Hello everyone, I hope you guys are doing good. So today we'll be covering another problem in our Blank 75 series, and the problem of the day would be problem 5, longest palindromic substring. So in this given problem, we have been given a string S, and we have to return the longest palindromic substring in S. So for this, the first thing we need to know is what is a palindrome. So any string that reads the same from left to right or right to left is a palindrome. For example, the string that I have written right now, this is a palindrome. And what does the problem ask us? The problem asks us that given a string, let's say S, let's take the example one. It's B, A, B, A, D. We have to return the longest palindromic substring. So as we can see, here we have two options. First one is BAB, and the another option is ABA. So we can return either of these two, and our output will be correct. So let's talk about how to approach this problem or how to solve this problem. So for this problem, what we'll do is we'll keep a track of two variables. Let's say the current variable, which would be a string, the current string or the current palindrome. And we'll also keep track of its length. Let's say current length, and let's initialize it to 0. And what we'll do is we'll start traversing a string S, and when we'll find a valid palindrome that is of a length greater than whatever the current length of the largest palindrome would be at that time, we'll update our current and we'll update our current length. So you must be thinking, how would we find a valid palindrome? So let's take a simple example from example 1, that's B, A, B, A, D. What we'll do is we'll start traversing a string, our input string S. And here we have two cases that could have happened. And one of the cases is we have an even length palindrome of length 2, 4, 6, and we have a palindrome of odd length. So let's consider the first case of, let's say, a palindrome of odd length. So what we'll do is we'll start our traversal, let's say from I equals to 0, and we'll initialize two pointers, let's say L and R, that would be initialized as the current index. And what we'll do is we'll start moving leftwards and rightwards of our current element, and will be within the bounds, that is, our left pointer would be greater than equal to 0, and our right pointer should be less than the length of string S. And if the element at L is equal to element at R, we know that we have found a valid palindrome. Let's say we are at A. When we are at A, our I would be equal to 1. So what we'll do is we'll first initialize our L and R pointers as 1 and 1. And what we'll do, we'll push our left pointer towards the left side, that is, our L would become 0. And our right pointer towards the right side, that's our R would become 2. And now we'll compare the string at 0, that's B, and the string at 2, that's also B. So in this case, we know that the middle element is same as we are considering a palindrome of odd length. The left one is equal to right one. That is, we have a valid palindrome. So we'll update our current and we'll say it's equal to BAB, and our current length, let's say CL, would be the index at R, that's 2, minus index at L, that's 0, plus 1. So our current length would be 3. So now we have to just keep doing the same. And whenever we find a new valid palindrome that has a length greater than the current length, we'll update our current variable. And at the last, we'll just print it. Now we'll be talking about what if we have a valid palindrome that has an even length. So for this, the only change we'll do is, rather than initializing L and R to I and I, we would initialize for even, we'll do everything same, just we'll initialize L and R as I and I plus 1. So what this will do is, let's say we have something like B, A, B. So let's say when we are at I equals to 1, we'll keep our L at I equals to 1. We'll keep our L as 1, R as 2, and now we'll move forward from R, move backwards from L, and compare both of the elements, and we see as they both are same, we'll just update our current, and we'll update the current length and move forward with it. So now let's discuss the favorite part of every viewer, the code. So as I said, we'll keep track of our current string, the current valid palindrome. We'll keep track of the length of our current valid palindrome, or the maximum current valid palindrome. Now, what we have to do is traverse our string. So for I in range len of s. Now we'll be talking about two cases. The case 1, let's say for odd. So in this case, what we have to do is initialize our left and right pointers as I and I. Then what we have to do is we have to check if our pointers are in bound. So the R pointer should be less than len of s minus 1, and the L pointer should be greater than equal to 0, and the value of s at L should be equal to the value of s at R. If all these cases match, what we'll do is we'll check if the length of palindrome is in the given condition, that is R minus L plus 1, is greater than the current length or the current maximum. And if this is the case, what we'll do is we'll just update our current as S of L to R plus 1, R plus 1 because the R plus 1 index is not being included. And we'll just update our current length or current maximum length as R minus L plus 1. After this, what we have to do is we just have to decrement our R, increment our R, and we have to decrement our left pointer and get out of the loop. Now we'll be talking about case 2, that is what if we have an even palindrome. So similar in this case, the only thing that changes here is L comma R would be now I and I plus 1. Other than that, we'll follow the same steps. We'll check if it's in bounds. So if R is less than len of S, my bad, it should be len of S, not I, because len of S minus 1 would be included. Len of S, and L should be greater than equal to 0, and S of L should be equal to S of R. And now we'll check if this new palindrome, a new valid palindrome's length is higher or larger than the current maximum length we have. If this is the case, we'll update our current as S of L to R plus 1th index, and we'll update our current length to R minus L plus 1. Similarly, we'll be incrementing our right pointer by 1, and we'll be decrementing our left pointer by 1. And at the last, we would just return our current. So let's check our solution. So as we can see, this is a pretty efficient solution. And talking about the time complexity, as we can see, we are traversing the array once. But other than that, we are also checking for the valid palindromes. So our time complexity would be, for the worst case, our time complexity would be O of n square. And the space complexity would be O of n. I hope you guys enjoyed the video. Thank you and have a nice day.